Bienvenidos, Ushamdeed, and welcome to another Hut 8 Consulting Techtorial on Cisco's Enterprise Networking, Security, and Automation course, which is part of the CCNA version 7 curriculum. In this activity, we're going to be turning our focus to Packet Tracer Activity 10.3.4, where we're going to configure and verify the Network Time Protocol, or NTP. Now, there are two versions of NTP that we're going to be discussing in this video, and here's what we're going to learn. We're going to look at the original RFC for NTP version 3, but then we're going to talk a little bit about NTP version 4. We're going to discuss the fact that NTP uses the User Datagram Protocol, or UDP, for transport, and it's using port number 123, right? So probably the easiest port number that you're going to end up having to remember, right? 123 NTP. Super simple. And we're going to be using NTP in a client-server model. We're going to be talking about the stratum values. And we're also going to be focusing on that show NTP status command, from which I could see a question coming up about the stratum value that gets listed out there, and something asking you whether or not that stratum value belongs to the device that you're on or the device from which you are getting your time, right? So pay close attention there. And then finally, we're going to compare and contrast NTP version 3 and version 4 and what the major difference is. All right, well, let's dive in here to the activity as it is set up for us. Now, we've got our addressing table here at the top. We've got an NTP server, right here, server PTN1. We've got a switch through which we're running router 1 and router 2. Now, the activity, again, is very straightforward. It's the devil is in the details, though, here with NTP, and we're going to talk about a number of these things. So the maximum hop count for NTP is 15, meaning a stratum value of 16 indicates that the device is unsynchronized. And you could even think about it as sort of like infinity, right? If you're trying to relate it to RIP, the routing protocol, right? So you would say that the stratum of 16 is device unsynchronized because it can't reach any time source and nothing is configured for it to be using as an NTP server. We're also going to talk about software clock and hardware clock, or system calendar. These are going to be important terms as well because you'll see these often. All right, so let's go ahead and dive in here. It wants us to take a look at server PTN1. Let's take a look at the services. And we'll come down here to NTP, right about the middle of the table. And you can see that NTP shows that it is on right up here, and that authentication, which is not covered in this activity and may be a little bit outside the CCNA scope, but keep in mind that you can use authentication, and this is critical in enterprise environments to make sure that you have some sort of authentication set up so that you are protecting your NTP information. All right, so August 2020, and we're going to go ahead and set the time to, and this shows 12, and so we'll set it to, and it doesn't roll around here. Okay, it's just going to give us to 11. All right, so it's about, what is it, 2:39, so we'll say 2, and I'll just type in 39 here, and we'll leave it. So 2:39 p.m., and hopefully, you know, my change here is going to hold through, and we'll see whether or not it does once we have those routers configured. So now it's asking us to check connectivity from router 1 and router 2 over to the NTP time server, 209.165, 200, 225. Probably lose the first packet due to the ARP request that's going to go out. And now let's come over and check from router 2 here, and we'll say ping 209.165.200.225. And again, we lose that first packet, but we've got reachability, and that's critical. We have to have reachability to the NTP server in order to be able to configure it, or configure on the router that NTP server as an NTP source of information. So now let me say show NTP status, right? So you can see NTP is not enabled. We haven't configured anything yet. Show clock detail. Now, this is important because learners will become confused when they hear the term system calendar or hardware clock, right? So on the motherboard of the router, the switch, whatever the device is that you might be working with, there's going to be a hardware chip, right, that has a battery that gets charged up when the device is plugged in, right? That's how it gets sort of reboosted. And if that device was to be reloaded, if it was to lose power, in other words, you unplug it, stick it on the shelf for a couple weeks, and then plug it back in, it's the hardware clock that would be keeping track of the time when the device is not synchronizing with an NTP server. And as you can see here, chances are maybe the battery died, and so what ends up happening is this goes back to sort of the date of inception, March 1st, 1993, because this is clearly nowhere near today's date, right? So Packet Tracer is showing us this time. This time is being kept. The source of that information is the hardware calendar. I'm going to show you how to set the hardware calendar as well. So the hardware calendar is where the time and date information is stored, right? And where the device is going to get that information. If that device is reloaded, it's got to have some way before it's synchronized with an NTP server to know what is the date and time, right? And it also has to know the date and time if the device is put on a shelf maybe, and you don't use it for a couple months, and then you grab it and plug it back in. And again, you'll typically see this if the device has not been used in quite some time. It's possible that that battery on the motherboard that's sort of backing that chip up to keep that hardware clock, that system calendar information that the system depends on, may have died, right? But it'll get charged back up when it gets plugged in. So now when I say show clock, this is showing me the software clock. And I know that and this is where it can become a little confusing, because you're probably saying, wait a second, you just said that the time is coming from the hardware calendar. Well, it is, right? But we're using iOS commands, the system software, to see what the time is. So this is what we refer to as the software clock. When I type in the command show clock or show clock detail, we're seeing the software clock information because it's what the software is telling me the time is. Now, where is the software getting that information? It's getting it from the hardware clock, or the hardware calendar, also referred to as the systems calendar, right? So hopefully that makes clear how this whole time thing works when we're not associated, right, or configured for an NTP server. So we took a look at the commands there. Again, this is a very simple activity. It's 50% for each of the routers, and all I need to do is say NTP server and then the IP address of the NTP server, 209.165.200.225. And we're going to say end write mem. I'm going to come out here to router 2, and we're going to do the same thing. I'm going to go into global config, NTP server 209.165.200.225. End, whoops, sorry, a little typo there. Let's pull this back. And that's not what I wanted. Get it back into global config, and that's the command I want back there. Sorry about that. 209.165, and I'll say write mem. Now, if I say show NTP status, and I say show NTP associations, we're going to see that the clock is unsynchronized. And there's the stratum value of 16. So if we're not synchronizing or not synchronized with an NTP server, is the stratum 16 value referring to an NTP server that we don't even know about? Or would it be referring to the device on which I'm running the show NTP status command and to which I'm logged in? And let's run that real quick. And you can see, and sometimes we can use a fast forward button here, but this is where I like to sort of segue out real briefly, and let's take a look at the RFCs. And so the reason I'm moving here is because back in this activity and in real life, I've seen it take up to 15 minutes before a device becomes fully synchronized with an NTP server. So don't think that you're going to say NTP server 209.165.200.225, hit enter, and then automagically, instantaneously, it synchronizes its clock, right? Now, that might happen, but typically there is going to be some time that you're going to have to wait until the devices synchronize with the NTP server. And so I'm using that time to real quickly cover some very important information here, right? Network Time Protocol version 3 was covered in RFC 1305 way back in 1992, right? So that's almost 30 years ago. So it's been a while for NTP version 3. Now, this is probably one of the more popular versions of NTP out there on devices that are on the network. However, as you can see, it was obsoleted, right? This RFC, the original, or I should say the original version 3 NTP RFC was obsoleted by 5905. If we come over here to 5905, you can see that it's the Network Time Protocol version 4. And one of the significant differences between version 3 and version 4 is that version 4 provides support for IPv6. Version 3 does not, because version 3 is actually sending out its UDP broadcasts. The NTP servers are IPv4, right? It has nothing to do with IPv6 when you're talking about NTP version 3. And so NTP version 4 brought IPv6 into the fold for NTP, right? Now, I highly recommend, and I guess we'll stick here, Ntp Overview talks about the stratum values, and that's what we were referring to. The lower the value, the more accurate, theoretically, the time source should be. And let me turn this off here. And so you can see right here that when we're talking about stratum, that stratum 1, a stratum 1 time server has a radio or atomic clock, which you could think of as stratum 0, directly attached to it, right? So it then sends time to a stratum 2 device. And so what that would look like is whatever and where's my drawing tool here? Let's get the drawing tool up. So if you have your NTP server, right, and I'll just put NTP server, and it's a stratum 1, any device, right, that's getting its NTP information is going to be stratum 2, right? And so then maybe this device is providing time, and then those devices, I'll just draw one, would be stratum 3, and so forth and so on. And the next device down here is going to be stratum 4, right? So you get the idea. And so I want you to think of the stratums, the number values, these integer values, as depicting the number of hops away from the authoritative time source. So this guy here might be directly connected to, and we'll just say, you know, A for the atomic clock. Well, he's 1 hop away, right? Because it's going to be 1 hop to get there. This guy would be 2 hops to get there. You know, 3, 1, 2, 3, so forth and so on, right? So you get the idea. And that's what the stratum values are all about. But I would highly recommend Googling Network Time Protocol Best Practices White Paper Cisco, because this document is filled with some really good information. And so you'll notice I said an atomic clock, right? And it's also, you can see, cesium fountain clock is a type of atomic clock. And NIST in Boulder, Colorado, serves as the United States, the NIST F1 cesium fountain clock serves as the United States' primary time and frequency standard. You can see the device over here on the right. That is not something you're going to be deploying in your data center, right? Let's just get that out of the way right now. And NIST has time servers that are publicly available on the internet to which you could synchronize your edge devices to, right? And then you could have your edge devices provide NTP information to devices on the inside of your network. And again, all kinds of information here if you were to Google that up. And then you could take a look here, NIST official time, and this shows you the official time. So again, some cool, it's just time.gov, right? So some very cool time features. And then I would recommend taking a look at Network Time Protocol version 4, which is just simply here in the Cisco community. And it actually points out, echoes what I've said earlier, is NTP version 4 is an extension to NTP version 3 for support for both IPv4 and IPv6, and it's backwards compatible with NTP version 4, and it goes into some of the enhanced security and some of the different, how it uses IPv6 multicast, right? Because there is no broadcast with IPv6, right? Remember that. So it's using multicast. So again, great sources of information as you continue your studies. And now we transition back to the packet tracer activity. I'm going to come over here and let's say show clock detail, right? So the software clock, which is now getting its time from an NTP server as the source, is reporting back. And take a look at that. It actually, no, it did not. So it didn't keep the date, right? It looks like it thinks it's August 12th. And actually, let's see, show NTP status. We should be synchronized at this point. We are. And so you can see it changed from Stratum 16 to Stratum 2. Because this device right here is being treated as a Stratum 1. Again, remember, Stratum 2 is not referring to the NTP server. That Stratum value right there is reflecting the Stratum value of the device that is synchronized to the NTP server. So you can see my clock is synchronized, my Stratum is 2, me router 1, and excuse me, the reference is, that's the NTP server from which we're getting the information. So again, as I was looking at that, that right there is begging to be a question somewhere down the road for you in your CCNA studies. All right, so that's show clock detail, show NTP status. How about a show NTP associations? And you can see we now have this asterisk here in addition to the tilde, and the tilde indicating that we've configured NTP, right? But that's not enough. We need to have that asterisk there showing the system peer relationship. Like, who are we peering to, right? 209, 165, 200, 225. And again, that is very, very important that you see both the asterisk and the tilde, and there's the IP address of the time server. So again, we've got 100%. Everything is configured here. But what I want to talk about now is why you hear the term hardware clock or system calendar. Remember, when I run the command and I say show clock or show clock detail, right? That is giving me the software clock because it's a software command that I'm running to get that value. There exists on real Cisco routers, and let's take a look at a real Cisco router right now. This is a 2811, and I turn this on and off all the time. And on this 2811, if I was to say show clock, and actually let's do router 9. And if I was to say show clock here, you can see that it's got the right date, right? August 29th, but that time is a bit off because that would indicate that it's about, because it's UTC time, which on the East Coast in Maryland, where I'm at, we should only be, should be a 4-hour difference. So, oops, sorry. So it should read, if it was add 4 to the current time, so it should be 18. So it's a little off right now, right? Needless to say, it's a little off. So the reason that the hardware clock is on the device, again, is because if I unplug it, if I throw it on a shelf, if I reboot it, the system has to have some reference for time. Because again, if I'm sending messages to an or SNMP traps to my solar wind server or something like that, I need to make sure, even if I'm logging locally on the device by saying, it's nothing other than show log, right? It would be nice if these dates and times that are in here, if these things were accurate. Because if they're not, and I'm trying to do some type of forensic investigation as to why my configuration got erased, it would be nice to be able to look at the SNMP trap maybe that got set on the syslog server, or to do a show log and to have accurate time, right? When you're troubleshooting, it is critical that you have the right time configured on the device. And whether that's locally configured with the hardware clock, the system calendar, or synchronizing with an NTP server, which would be preferred in a larger environment, that time is critical. So the hardware clock, right? If I say show clock or show clock detail, you can see time source is hardware calendar. And that's where those two terms come from. The system calendar, because you could actually say show calendar as well, right? And that's going to give me sort of that same information, right? So how do we change that? How can we set that? Well, I can do it right from here. I can say calendar set, and I believe it's going to be, what is it, hours? Yeah, so we'll say 18:56:00, and then 29 August, AUG 2020, right? So now this is key. What I'm showing you here is key. So I would set this if I'm not going to be using NTP, right? And you would want to set this anyway to give it, some kind of a reference that's accurate, especially if you power it up and it says it's March 1st, 1993. So we've just set the calendar, but I want you to watch. If I say show clock now, and we'll say show clock detail, the time didn't change. What if I say show calendar? Now, show calendar changed, but the clock didn't. And this throws a lot of junior network admins and learners for a loop because they don't understand why the calendar got updated, but the clock didn't. Remember, I set the calendar here to get that information to push to the clock, right, to the hardware clock. I would have to say read calendar, right? And this is going to read the hardware calendar into the clock. In other words, it's going to read that information that I just set into the clock. And so let's say read dash calendar, and that should be it. And then there's an update calendar as well. And so we'll update the hardware calendar from the clock. We'll do the same thing. And now when I say show clock or show clock detail, you can see that we now have what we're considering for this activity to be accurate time and accurate calendar information because this device doesn't use an NTP server. But remember, it's in a week or maybe a month, you're going to have drift and skew. I can guarantee it with these hardware values, especially if you're powering the device off and then powering it back on and then putting it on a shelf, maybe not using it for a while. So again, keep those things in mind. Very, very important that you've got accurate time information on your Cisco devices. And that is going to do it for this activity Packet Tracer 10.3.4, where we configured and verified NTP, and we talked about a ton of additional information that is critical for you to understand as you make your way through CCNA studies. All right, thank you so much for watching. All the best of luck to you out there on the wire, and I hope to see you in the next video.